Neglected, far compasses of our nearby planet group, an old monster stirs. It all started billions of years ago, and now, in a cosmic irony, Pluto, a tiny, seemingly insignificant planet, is the subject of one of the most heated astronomical debates of our time. Neil deGrasse Tyson and Michio Kaku, two well-known scientists, have raised concerns about a possible collision with Neptune that could alter the course of our solar system and have an impact on Earth. How did this vast dance start? What's the significance here for us? And might we at some point be going to observe quite possibly of the most terrible occasion ever? When considered the 10th planet in the planetary group, Pluto was downgraded to a bantam planet in 2006 by the Worldwide Cosmic Association, IAU. This arrangement depends on its interesting circle and little size contrasted with different planets.
Gamma-ray telescope
Be that as it may,
for unseen
notwithstanding the downgrade,
stars of the galaxy.
Pluto keeps on entrancing stargazers and the overall population. Lately, expectations by conspicuous astrophysicists, for example, Neil deGrasse Tyson and Michio Kaku, have caused serious worry about Pluto's circle. These forecasts point to a catastrophic collision with Neptune, which could have far-reaching effects for Earth and the rest of the solar system. But how did Pluto get to be in this position? And are there any chances that this tiny, icy world will collide with one of the giants in our solar system? Pluto's excursion around the Sun is not normal for some other planet. It takes Pluto 248 years to complete one orbit, and it has not done so since its discovery in 1930. The incredibly lengthened, frosty nature of its circle, which is slanted 17 degrees from the plane of the ecliptic, the fanciful level surface around which the vast majority of the planets spin, adds to the secret. This surprising way permits Pluto to cross Neptune's circle for a considerable length of time in each circle. During this time, Pluto draws nearer to the Sun than Neptune, opposing assumptions in view of their situations in the planetary group. This change ups the ante in a high-stakes space game, a game with possibly hazardous outcomes. At the point when Pluto crosses Neptune's way, the gravitational powers between these two divine bodies become a vital consider deciding their fates. These interactions have changed over time, making an already complicated situation even more complicated. The dance among Pluto and Neptune features the powerful idea of our nearby planet group. However, Pluto was once viewed as a forlorn exception in the external districts. Its nearby experience with Neptune exhibits the interconnectedness of every single heavenly body. Each applies inconspicuous powers that shape the ways of others, making a sensitive equilibrium that, when upset, can prompt incredible bedlam. Propels in observational innovation have permitted space experts to follow Pluto's developments more exactly than any other time in recent memory. Because of this, we now know more about its orbit and what it might mean for the stability of the outer solar system. While the likelihood of an immediate crash among Pluto and Neptune is low, it can't be completely precluded. The chance of such an occasion has prompted kept checking and research by the cosmic local area. A lot is on the line, as even a little impact could send shockwaves through the whole nearby planet group. Given the intricacy of Pluto's circle, one could ask why a horrendous crash among it and Neptune has not yet happened. The gravitational forces at work, which have so far prevented the two celestial bodies from colliding, provide the answer. However, Pluto's circle is sporadic. It is steady. Stargazers have distinguished different instruments that assist with keeping up with this solidness. For example, a peculiarity known as mean movement reverberation. In essence, Pluto and Neptune are entangled in a relationship of gravitation that prevents them from colliding. Be that as it may, the issue isn't altogether tackled. The perplexing dance of gravity, orbital mechanics, and time keeps on planning to bring these two bodies into a possibly lethal crash. In celestial mechanics, the three-body problem is a concept that describes the intricate gravitational interactions between Pluto, Neptune, and the Sun. Tackling this issue is especially difficult in light of the fact that it includes foreseeing the movements of these particles in view of their gravitational cooperations, a troublesome errand given the turbulent idea of these cycles. On account of Pluto and Neptune, their circles impact one another, but on the other hand are impacted by the gravitational draw of the Sun. The outcome is a sensitive equilibrium that can be handily upset by even the littlest irritations. Let's say Pluto and Neptune do come into contact. The energy let out of such a crash would be huge, sending shockwaves all through the planetary
Liftoff
group.
of the Delta
Sections from
rocket
the
carrying
effect could
Glass,
strike different
a
planets
gamma ray
or
telescope
moons,
searching
creating
for
additional
unseen physics
obliteration.
in the
The
stars of the
gravitational
galaxy.
balance that has kept our planetary group intact for billions of years could be upset, with outcomes that are challenging to anticipate. Scientists cannot completely ignore the threat, even if a collision does not appear imminent. The fragility of our cosmic neighborhood is starkly demonstrated by this scenario. Neil deGrasse Tyson, an incredibly famous astrophysicist, has examined the perils presented by Pluto's uncommon circle. He has expressed that the renaming of Pluto as a bantam planet was a step in the right direction in how we might interpret the nearby planet group. In any case, he recognizes that Pluto's circle stays a secret yet to be completely unwound. Tyson's partner, Michio Kaku, offers a captivating point of view on this theme. Known for his work in string hypothesis, Kaku accepts that concentrating on peculiarities like Pluto's circle could give significant bits of knowledge into the fate of room investigation. He suggests that learning about the orbital dynamics and gravitational interactions of celestial bodies like Pluto could improve our ability to safely navigate the solar system and future space missions. Kaku's advantage in Pluto's circle reaches out past simple scholastic interest. He thinks that the cosmic dance's gravitational forces could be used to test predictions of string theory, a theoretical framework for explaining the universe's fundamental forces and particles. As per Kaku, a crash among Pluto and Neptune, while crushing in its nearby effect, could offer an exceptional observational open door. The behavior of fundamental forces and particles in extreme conditions, as well as the frequency and intensity of the gravitational waves produced by such an event, could provide crucial information for string theory research. Both Tyson and Kaku concur that studying Pluto's orbit is essential for space exploration in the future. As mankind adventures further into space, understanding the complicated communications between heavenly bodies becomes significant for arranging protected and fruitful missions. It's possible that the lessons learned from Pluto's orbit could be applied to other planets, preparing us for space travel. By developing our insight into the nearby planet group's unpredictable mechanics, we can all the more likely get ready for the difficulties that lie ahead in our journey to investigate the universe. In spite of advances in how we might interpret heavenly mechanics, the universe stays a position of vulnerability. The hypothesis of orbital disorder, the possibility that little changes in the position or speed of a divine body can prompt critical modifications in its circle, advises us that even the most steady frameworks can be unusual. Researchers utilize progressed reenactments to show the associations of heavenly bodies like Pluto with others in the nearby planet group. These reproductions uncover that what at first shows up as tumult may really be an unobtrusive equilibrium of powers. Scientists hope to learn more about the universe and our place in it by studying these interactions. Even though it's unlikely that Pluto and Neptune will collide in our lifetime, the possibility exists. We become more aware of the potential threats lurking in the far reaches of our solar system as our comprehension of the cosmos grows. Pluto's circle fills in as an update that the universe is a dynamic and consistently evolving place. The powers that administer the movement of divine bodies are intricate and frequently challenging to foresee. We must remain alert and prepared for the unexpected as we continue our exploration of the universe. The likely impact among Pluto and Neptune is only one illustration of the numerous vulnerabilities that exist in our universe. As researchers keep on concentrating on these peculiarities, they are helped to remember the delicate idea of the nearby planet group and the fragile equilibrium it keeps up with. Our unrelenting pursuit of knowledge in space exploration is exemplified by the ongoing investigation of Pluto's orbit. A journey that challenges our imaginations, expands our horizons, and inspires generations of explorers and scientists. Each discovery brings us closer to comprehending the universe's complex nature. Looking forward, the likely impact among Pluto and Neptune fills in as a strong sign of the limitlessness and unconventionality of the universe. It's an update that, in spite of our earnest attempts, we are as yet liable to powers a long ways unchangeable as far as we might be concerned. However, it is likewise a demonstration of the force of human interest and the getting-through journey to grasp the universe.